Solutions for quiz 6 for Math 111. In this first problem here, first of two, I think. Yeah. You have to find the inverse of two of these three. So you don't have to do all of them. I'll do all of them so that you have solutions for all of them. But basically, you're given three functions, asked to find their inverse. So for this first one, the one with the mess of twos, your first step on all of these, is, let me copy down this big mess, hopefully correctly. Change f of x into a y. Easy enough, just changing notation. The reason you do that is because your second step, you want to solve for x. And to solve for x, it's a lot easier to have a y over here than an f of x. So let's see if we're solving this thing for x. The first thing we'll do is add 2 to both sides. I think I might have gone a little overboard with these 2's. But whatever, we can deal with it. And then divide both sides by 2. And then subtract 2 from both sides. And now multiply both sides by 2. So let's jump up here. Let's see, you got some options here. I'm just going to multiply both sides by 2. Y plus 2 over 2 minus 2, quantity times 2. Whoa, what did I do there? Messed that up. Alright, let's see, if I'm multiplying both sides by 2, I got 2 times y plus 2 over 2 minus 2. And that's equal to 2 times x plus 2 minus 2. So trying to uncover this x here, so now I'll add 2 to both sides. If I divide 2 again, do I want to do that? Oh man, this problem's annoying. Yeah, okay, so you divide both sides by 2. But what I was thinking is you could simplify that a little bit also. But you don't have to simplify. So I'm not going to simplify till the very end, just so if you get an answer, I want it to look like what I'm saying is a correct answer. Okay, so anyway, subtract 2 from both sides, and we got x equals 2 times. Up here I got y plus 2 over 2 minus 2, and plus 2, and then divided by 2 minus 2. If you really wanted to, this is perfectly fine, or you could simplify this thing. Let's see, what's the easiest way to simplify this? Well, this 2, could break this up into 2 terms. Okay, so I could factor out a 2 from these 2 guys and cancel it with this 2 here. So this 2 is time, okay, anyways, what you'd get is y plus 2 over 2 minus 2 plus 1. Minus 2, which, let's see, minus 2 plus 1, that would be minus 3. And if I got a common denominator, it would be 6/3, so I could say it's y minus 4 over 2. You know, I think I'm just going to leave it. Let's just leave it. So you get here, change the notation so it's f inverse of x is equal to 2 times x plus 2 over 2 minus 2 plus 2 divided by 2 minus 2. Maybe I'll simplify this later so I can show you other answers, but I'm fine with this just like this. Let's move on to the next one. On this next guy, I think I won't need quite as much room. Trying to find the inverse of this radical function here, kind of meaning I got a fraction. And the easiest way to do that, multiply both sides by 3 minus 2x. And then if you distribute this y, sneezing these a couple times. We want to solve for x, so we want to get all the x's together on the same side of the equation. To keep things positive, I think I'll add xy to this side and subtract 1 from this side to get 3y minus 1 equals 3x plus 2xy. And now I can factor out an x from these guys and get 3 plus 2y is 3y minus 1. In other words, x is, if I divide both sides by this thing, I'd get 3y minus 1 over 3 plus 2y. Yeah, lots of other ways you could write this. Another way this might come out if you do the algebra in different orders is 1 minus 3y over negative 2y minus 3 maybe. Lots of different variations, something like this. So you're actually, before I write it in a different form, I want to write it in the right notation. So let's go up to here and say g inverse of x is equal to 3x minus 1 over 3 plus 2x. And I'll even say, some of you might have come up with 1 minus 3x over negative 3 minus 2x, which is fine. Either of these are totally good. Just wanted to write both in case you were looking at the solutions and you saw one and not the other and got scared. Alright, and then this guy, y equals x squared minus 10x plus 6. It's hard because I got an x squared and an x. The solution for that is to complete the square, but I don't have a perfect square. I got x squared minus 10x. If I had x squared minus 10x plus 25, I'd have a perfect square. But I don't have plus 25. I just wrote that out of nowhere, so I better minus 25. So add 25 minus 25, you're not changing anything, but now you got a perfect square over here. You got y equals x minus 5 squared. That's all this stuff. And then minus 25 plus 6 looks like minus 19. And the advantage of this form is now I can solve for x. Add 19 to both sides. Take the square root of both sides. Normally when you take the square root of both sides of an equation, you have to put in the plus or minus. However, since we restricted the domain to the positive half here of this parabola, we don't end up with a negative square root here. So if we add 5 to both sides, you get x equals the square root of y plus 19 plus 5. In other words, h inverse of x is the square root of x plus 19 plus 5. Second problem, here's g of x. Express this in this form. Okay, the way we'll do that, basically it's completing the square. So start by saying g of x equals, can't complete the square if I have 2 as a leading coefficient, so let's factor out that 2. And then we'll kind of work inside the parentheses to complete the square. See, inside these parentheses, I don't have a perfect square. I got x squared minus 4x. Let's see, if I had a plus 4, I'd be in good shape. I don't have a plus 4. I can put a plus 4 as long as I put a minus 4 also and get here. But the advantage of doing things this way is now I got this perfect square. I got 2. This right here is a perfect square. It's x minus 2 squared. That's all 3 of these terms. And then minus 4 plus 3 is the same as minus 1. Not quite in the right form, but if I take this 2 and distribute it through, I get 2 times x minus 2 squared minus 2. So here's g of x in that notation. Find the vertex. Well, if this were just x squared, the vertex would be at 0, 0. The minus 2 here shifts it to the right by 2. And this shifts it down by 2. So let's see, from 0, if I go right 2, my x-coordinate becomes 2. If I go down 2, my y-coordinate becomes negative 2. So my vertex is at 2, negative 2. Find the x-intercepts. Okay, x-intercepts happen when the height of this function equals 0. So when 2 times x minus 2 squared minus 2 equals 0. If I add 2 to both sides, I can then divide both sides by 2. I can take the square root of both sides of the equation x minus 2 equals plus or minus the square root of 1. Square root of 1 is just 1. So I get x minus 2 equals plus or minus 1. X equals 2 plus or minus 1. That is x equals 1 or x equals 3. Find the y-intercept. The y-intercept happens when my x value equals 0. So I guess I can write this. Find the x-intercepts. That's when g of x equals 0. The y-intercept happens at g of 0. So if I go to my original function here, I got 2 times 0 squared minus 8 times 0 plus 6. 2 times 0 squared is 0. 2 times 0 is 0. 0 minus 8 times 0 is 0. 0 minus 0 is 0. Plus 6 is equal to 6. So my y-intercept is at y equals 6. Maybe I'll say y equals 6 or x equals 0, y equals 6. And for these, I'll say this, or x equals 1, y equals 0. All these ors are confusing. Let's say and here. Or we can write this and this. Makes sense? Y-intercepts, x-intercepts. I think that's it. So that is the end of quiz 6.